everybody, Dr. Nelson here. This is a brief video about something called scaled copies. All right. Hopefully by watching this video, it'll give you a nice preview of what you're about to learn in math class, or maybe you can use it to help you study for a quiz or test. All right. So what exactly is a scaled copy? Let me first by showing you some examples that you have probably seen before where you live. Okay. So here we have an image of a billboard, right? Maybe you're driving in your parents' car or say a bus, and you look over to the side of the road and you see a giant image of an advertisement, right? Or maybe you have an image on the side of a bus that is advertising a movie or maybe an album, right? Or maybe you live in a city and you have a giant advertisement on the side of a building, like say in Times Square in New York City, okay? All three of these are an example of a scaled copy, all right? A really famous example is in Cleveland, where this is a scaled copy of a Nike advertisement about LeBron James. Okay, LeBron James is a basketball player who played in Cleveland. When they made it to the championship, they had this giant Nike advertisement that featured LeBron James. Okay, now at one point, I'm sure that this giant image was a smaller image on someone's computer, and they had to blow this up into a scaled copy. All right, so what exactly is a scaled copy? Okay, a scaled copy is a copy of a picture that changes size but does not change in shape. Okay, so notice I highlighted two key words, size and shape. Okay, so scaled copy is a copy of a picture that changes size, right, but does not change in shape. So take a look at this example. Okay, here we have three dogs. Okay. We have original Dalmatian, and we also have two other images, okay? Picture one or picture two is a scaled copy of the original, all right? Now, before we tell which one is which, okay, remember, a scaled copy is a duplicate of a picture with no parts of it distorted, though it can be larger, smaller, or the same size, all right? So can you tell which one of these is distorted compared to the original, all right? Is it picture one or is it picture two, okay? And the correct answer is, notice picture one, it looks stretched, right? It looks like the width got stretched, right? So this is not the same image as the original, where picture two is the exact same dog, okay, except it's larger, okay? So picture number two is the scale copy of the original, all right? Let's look at another example. Here we have four happy faces, okay? And the question is, which of these three pictures, picture one, picture two, or picture three, okay, is a scaled copy of the original. All right, can you tell which one it is? All right, well, the correct answer is picture number one. Okay, picture number one is literally the same as the original, except it got larger, right? It's the same shape, but different size, okay? Where notice picture number two and picture number three, okay, are distorted. All right, it looks like picture number two, while it's a happy face, right? It looks like the height got stretched, okay? And picture number three, okay, it looks like the width got stretched, okay? So again, a scaled copy has to be the same image, but just a different size. All right, so how can you tell if an image is a scaled copy of another image, all right? So what you gotta do is, here we have an original image, which notice is a rectangle, all right? And then a new image, which is also a rectangle. So the question is this new image, okay, a scale copy of the first one? So the way you do this is you have to first measure the dimensions of the sides, okay? So notice the height of this shape, right, is 2, right? And the width is 1, 2, 3, 4, and 5. All right, so the ratio of the height to the width is 2 to 5. This one over here, the height is 1, 2, 3, and 4. And the width is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Again, the way I figured that out is I measured the distance from this point to this point. So the ratio of the original is 2 to 5, and the ratio of the new image is 4 to 10. Now, let's focus first on these two heights, the 2 and the 4, okay? Notice, to go from 2 to 4, I doubled it, or I times it by 2, okay? And now, when I look at the widths, to go from 5 to 10, notice if I multiply 5 times 2, I also get 10, right? So because both dimensions are multiplied by 2 to get the new image, okay, we know that this new image is a scale copy, okay, of the original. Let me show you one other way to do that too. For this one, I'll use a different color. And let's do this, okay? Let's say we also, this original image, we knew the ratio was 2 to 5. And we know the ratio of the new image is 4 to 10, right? Well, one secret you can do is if the cross products are the same, so 5 times 4 is 20, and 2 times 10 is 20. If the cross products are the same, that's a sign that the new image is a scale copy of the original. All right, so the question is the new image, okay, a scale copy of the original, okay? Now notice the original is larger than the new image, right? So the image is being shrunk a little bit, but we want to know, is it a scale copy? Okay, so again, the way you tell is you measure the dimensions. So I know the base is going to be 1, 2, 3, 4, 5, 6, 7, 8. All right. And I know the height is going to be 1, 2, 3, 4, 5, 6, 7, and 8. So both the base and the height of this first right triangle are 8 and 8. Now this one over here, all right, the base is 1, 2, 3, 4. And the height is also 1, 2, 3, and 4. Okay? So notice, to go from 8 to 4, we divided by 2. And to go from here, this 8 to 4, we also divide by 2. All right? So because we divide by 2 for both dimensions, it's a scaled copy. All right, let's take a look at this one. Okay, so again, is the new image a scale copy of the original? Okay, now hopefully you can tell already the answer is no. Okay, the second image is not the same shape as the first image, but let's prove why. Okay, so let's first measure the height of the circle. Okay, so we're going to measure from here to here. So that's going to be 1, 2, 3, 4, and 5. Okay, and let's see how wide it is as well. So we're going to measure from here to here. And this is also 1, 2, 3, 4, and 5. Now for the oval, notice that the height of the oval is going to be 1, 2, 3, 4, which is okay. But notice the width of the oval is 1, 2, 3, 4, 5, 6, 7, and 8. All right. So because this got stretched out, right, the ratio is different. But again, we can use ratios to figure it out. So let's go 5 over 5, and then 4 over 8. And then if the cross products are the same, we know that it's a scale copy. And guess what? 5 times 8 is 40. And because 20 does not equal 40, it's not a scale copy. All right, hopefully you're starting to understand a little bit more about just what is the scale copy. Let's go on to this one. This one involves SpongeBob. Okay, so again, the question is this new image, okay, a scaled copy of the original? So again, one more time, we're going to measure the dimensions. So I know this SpongeBob, okay, the width is 2. It looks like the height is 3. And the width of the new image, which might be a scale copy, is 1, 2, 3, 4, 5, 6. And the height is 1, 2, 3, 4, 5, 6, 7, 8, and 9. All right. Now notice, to go from 2 to 6, that's times 3. And then the heights, to go from 3 to 9, that's also times 3. All right. So because it's the same, all right, times 3, we know it's a scale copy. But again, let's also compare the ratios of the sides. So we have 3 to 2 and also 9 to 6. And look at this. If you cross multiply, 9 times 2 is 18, and 3 times 6 is also 18. So again, this copy of SpongeBob is a scale copy of the original. All right, here's our last problem together. All right, it says, which of the following is a scale copy of the original? So notice we have the letter A. Okay, this is our original copy. And we have figure 1, figure 2, which is a larger A. Figure 3, which is like a little bit slanted, right? It looks like it's leaning this way. And then figure 4, which is smaller. So first of all, can you tell which one of these automatically is not a scale copy? Because remember, a scale copy has to be the same shape. Okay? So if you look at figure 3, notice figure 3 is not the same shape as figure A, right? So we can just automatically cross this one off. All right. But now let's look at figure 1, figure 2, and figure 4 to see if they're a scale copy of the original. So first thing we have to do is we have to measure the dimensions of the original. So notice that the height is 1 and 2. All right, so from here to here, it's 2. And the width is also 1 and 2. All right, so the height and width are 2 and 2. Now let's measure, right, figure A, the height. So the height is 1, 2, and 3. So from here to here is 3. And then the width is 1 and 2. Now notice the height and width of this shape are the same numbers, right? So that we need the same ratio over here, and 3 to 2 is not the same as 2 to 2. So we know this one is not a scale copy. Let's try this for also figure number 2. The height from here to here is going to be 1, 2, 3, and 4. And the width is also 1, 2, 3, and 4, right? So because 4 over 4 is the same as 2 over 2, we know that figure 2 is a scale copy. Let's do one more. Here we have figure 4, right? Figure 4, the height is 1 and the width is 1. All right, again, because 1 to 1 is the same ratio as 2 to 2, right? We know figure 4 is a scale copy. All right, so the correct answers for this one was figure 4 is a scale copy and figure 2 is a scale copy because they're both the same shape but a different size.